Hello students, good evening to all. Welcome to ACE Engineering College. Myself Subrahmanyam. I'm having 19 years of teaching experience, teaching for electronics and communication engineering students. Right now I'm going to teach you very important concepts and very important questions which you can expect in the examination, that is in your university examination. As a part of revision series, our ACE Engineering College have planned to give this opportunity to many students, those who are preparing for b.tech courses. Not only ECE, we have other branches also. As a part of electronics and communication engineering, I am here presenting previous year's questions as well as solutions for them from the subject of electromagnetics, which is unique for all universities. Like many universities we have in the state and central. As a part of that, we have electromagnetics. Other universities, they might have called it as electromagnetic waves and transmission lines, electromagnetic fields and waves. Finally, our core area is electromagnetics. Okay, so myself, Subrahmanyam, I'm going to give you, without wasting your time, valuable time, I'm going to present various important questions from the previous years, which I have taken from different universities, which are very, very important for your final examination as a part of your preparation. Okay? Yeah, major topics from this, I have taken 5 topics: electrostatics, magnetostatics, then time varying fields. Under that we have Maxwell's equations, then we have EM waves, how to create an EM wave, then finally we are going to have waveguides from that. Okay, the first one I'm going to give you here, electrostatics, which is due to charge at rest. When the charge is at rest, what is the field we have? Basically, electromagnetics is dealing with 2 fields: when the charge is at rest, when the charge is in motion. The charge at rest, which causes static electric field. Under that we have electrostatic field. We have a special case in that, electric field intensity and electric flux density. Then we have moving charge. If charge is moving with a constant velocity, which attains a steady current or DC current, which causes static magnetic field, or we can say steady magnetic field, we have magnetostatics. Under magnetostatics, we are going to analyze magnetic field intensity and magnetic flux density. Before having the session for magnetic field, let us finish electrostatics today. Okay? Yeah. So as a part of electrostatics, I'm just giving you major topics that we are going to have here. Coulomb's law. Using Coulomb's law, we are going to introduce electric field intensity. So we have electric field intensity, and later we have Gauss law. Then work and electric potential. Finally, we have capacitance of capacitor. So with the help of analysis of electric field and electric flux density, we have one of the application, which is electrical device called capacitor. Capacitor is an electrical device capable of storing the energy by means of electric field, which is half CV square in the form of potential in network theory. In circuit theory, we have half CV square. They are under lumped parameters. Whereas in field theory, we have distributed parameters, epsilon and E. Epsilon is measured in farad per meter, whereas V is measured in volt. Electric field intensity is measured in volt per meter. Field strength per unit length. Yeah. The next one, let us have one of the important question as a part of Coulomb's law. So what we have here, state and explain Coulomb's law in vector form. This is the most important question they asked in many universities in their final or external examination. Also, I have given one numerical question here. Find a vector force on a charge minus 100 millicoulomb located at point P 2, 0, 5 in free space due to another charge that 300 millicoulomb located at point Q 1, 2, 3. Before having this numerical value, I'll just give you formulae how to use this Coulomb's force equation and how to solve this question using Coulomb's force equation. That is very important. Dear students, as a part of your preparation, you might be preparing for exams, but the presentation of your solution in the exam hall is important. That is very, very important. Look at here how I am presenting the solution for various numerical questions. Okay, yeah. We know the statement of Coulomb's law that you might have learned from Charles Augustin de Coulomb has given the analysis of force between two objects when they carry point charges. Point charge is nothing but charge confined to the object size. Basically, these point charges are very small in size. They are very small in size. Look at the dimensions of the charge, whatever we have. We have taken Q1 and Q2. Usually they'll be measuring in the order of milli, micro, nano, femtocoulomb or picocoulomb like that. So compared to dimension, which is the spacing between the objects that we have, these charges are very, very small in size and they are having very little quantities. Yeah, we know the statement of Coulomb's law. And dear students, this is one of the important question that you can find in short answer questions. Many universities, they will be having short answer questions before the long answer questions that you have. They are also very important. We can't neglect. So as a part of short answer questions, you can have divergence theorem. In EMF, I'm talking. Divergence theorem, Stokes theorem, Coulomb's law, Gauss law, Ampere's law. All these statements are very, very important. Directly they are asking in the exam as a short answer question. Okay? Yeah, they can ask in the exam. Instead of long answer, they can also ask in the short answer question. It states that the force between two small objects separated by distance d or r is directly proportional to product of charge on each object. Suppose object 1 is having charge q1, another object is having charge q2. It is proportional to product of charge contained by each object, means q1, q2, and is inversely proportional to square of the distance between them. I'm just showing here how we can show it mathematically. So we have two objects. Let us take this is object 1, which is q1, contains a charge q1. We have another object, say, which contains a charge q2. The separation between them or spacing between them is RD, we can say. Charles Augustin de Coulomb has initially taken these two objects were kept in a medium of free space or a vacuum. So let us assume our medium is free space or a vacuum. In free space, we know permittivity of free space is epsilon naught, because for free space or a air or a vacuum, epsilon r is 1, where epsilon r is called relative permittivity. I'll talk about it later. Now, let us assume the force on Q2 due to Q1, because the charge Q1 is at rest, which causes force on Q2, means the charge Q2 will be influenced by charge Q1. Similarly, the charge Q2 is sitting here, is influencing another charge Q1. Okay, how they are influencing, how to find the magnitude, its strength, and how, in what direction the force is oriented between these two objects. To decide that, at any cost, we should know vector form of Coulomb's force equation. Before that, I'm just giving you magnitude force, what is the force between them. Let us take the force between them is depending on charge contained, whatever the charge which we have, force is proportional to product of charge on each object and is inversely proportional to square of the distance between them. From this we can write Coulomb's force equation in magnitude form, F equal to K Q1 Q2 by R square. This is a basic equation. But according to his mathematical approach and his practical analysis, Coulomb has taken this proportionality constant as 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. We have Q1 Q2 by R square. So whatever the force I have given here, this is a magnitude force. But what I have told, in general, the magnitude force, if you observe here, it is depending on 1 by 4 pi is a number, it is a value. It doesn't have any effect. Where it is depending on permittivity. So in general, what is the permittivity here in general? Epsilon is epsilon naught epsilon r. Epsilon is the permittivity of the medium. Permittivity has the ability to allow electric energy by means of half epsilon E square, which is energy density in electromagnetic fields, joule per meter cube. It has the capacity or it has the ability to allow energy in the form of electric field. If I consider a medium is free space, definitely epsilon r must be taken as 1. For free space, epsilon r is 1, except free space, any medium, if you take a glass, fiber, anything, mica, quartz, all these are having relative permittivity which is greater than 1. That is the reason why when the electromagnetic wave is traveling in free space, it can travel with velocity of light which is 3 into 10 to the power of 8 meters per second. Except free space, any medium you take, velocity will be less than the free space velocity. That is the reason why when you send an electromagnetic wave from the Earth station to the moon, there is a lunar orbit, there is a satellite which is there in the lunar orbit. If you can transmit the electromagnetic pulses every second, almost for every second you can transmit. How? If you observe the distance from the Earth to the moon is approximately 380 megameters. As the wave which is traveling in free space with 3 into 10 to the power of 8 meters per second, then if you just calculate time it takes to reach the lunar orbit, t equal to s by v, 380 into 10 to the power of 6 by 3 into 10 to the power of 8, you will be getting around 1.27 seconds. By sitting in your office or in your room or research center, if you transmit electromagnetic waves now, it will reach the lunar orbit of the moon, which in 1.27 seconds. That is the beauty of electromagnetic wave which is traveling in free space. Any medium except that will be less than the velocity of light. Yeah, let us come to this. As epsilon r is 1 for free space, he was taken 1 by 4 pi epsilon naught. That ready-made value we can take directly. Before that, I am just giving you what is epsilon naught value. Here, epsilon naught is 8.854 into 10 to the power of minus 12 farad per meter. Or we have another equivalent 10 to the power of minus 9 by 36 pi. This also we can take. Both are same, dear students. Both are representing same. No change. If you want, you can verify by calculating this above one you can get. Or else if you just substitute here 1 by 4 pi epsilon naught, as epsilon naught is 10 to the power of minus 9 by 36 pi, then if you substitute that 4 pi by 36 pi, it is 1 by 9. 1 by 1 by 9 becomes 9. 10 power minus 9 will come to the numerator as 10 to the power of 9. So the value of 1 by 4 pi epsilon naught we can take directly while solving the problems, that value as 9 into 10 to the power of 9. Dear students, remember, whenever you are calculating capacitance of any configuration, you have to take epsilon naught is 8.854 into 10 to the power of minus 12. Even you can take this also, nothing will happen. But if you take directly, you can get the numerical value without any fractions. Okay? Yeah. Now, according to Coulomb's law, the magnitude force which is measured in Newton, which is named after Professor Isaac Newton, one of the great mathematicians. Okay, so we have F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where the force which is directly proportional to charge contained by the each object and is inversely proportional to square of the distance between them. Not only that, it is also depending on permittivity. But what about vector force? That is very important for us. This is just magnitude. The vector force which acts along the line connecting or the line joining between the two objects, it can be attractive or it can be repulsive. Depends the polarities of the charges that you have taken. If two charges are of the same polarity, there will be repulsive force between them, like plus plus or minus minus if you have taken, then there will be repulsive force between them. If they are having opposite polarity plus minus or minus plus combination, then the electrostatic force between them is attractive. So we can't we prove it mathematically or can't we tell mathematically? Yes, we can tell if you could express the force which is in vector form. That I'm going to give now. Yeah, I'm just showing here. So we have a charge Q1 which is located with respect to origin at some position vector R1 bar, and charge Q2 is located at some position vector R2 bar with reference to the origin. Every coordinate or point is measured with respect to origin only in the space, that we know. Now, if I wish to find vector force on Q2, vector force on Q2 due to Q1, force on Q2 due to Q1. Remember, this is very important. If you wish to find the effect of charge Q1 on Q2, the tip of the arrow must be pointed towards the direction, towards that object Q2. This is very important. This is called conventional direction that we are taking initially to measure the actual force, whatever it is existing. Then I must take displacement from position 1 to position 2. How do you measure this position displacement R12 bar? Initial point is 1, final point is 2. Always displacement drawn from 1 to 2 or initial to final is final minus initial. Very important, dear students. This notation will be following till the end of this electromagnetic subject. So always displacement from initial to final is final minus initial. Similarly, if we wish to find force on Q1 due to Q2, let this is F21 bar. F21 bar. What we are doing here, the charge Q2 is sitting here, is influencing another charge Q1. Nothing but the charge at rest Q2 is influencing Q1. If you assume Q1 and Q2 are having same polarities, then what is happening? This Q1 will be repelled away from Q2. That we can find mathematically by using our vector form of Coulomb's force equation that I am going to give now. For that, what we need, if we wish to find force on Q1 due to Q2, I must draw the displacement from 2 to 1. Let us take this is R21 bar. So what is R21 bar here? Displacement from 2 to 1. 2 is initial, 1 is final. Then final minus initial, 1 minus 2. So I'm just giving you this information. R12 bar is nothing but R2 bar minus R1 bar. Similarly, R21 bar is nothing but R1 bar minus R2 bar. These are very important, especially when you are finding the force in vector form. You must have the knowledge of this. This is from the vector algebra basically, but here also I am giving you this information to understand how we are solving the displacement and how we are finding direction of force. Okay? Yeah. I'm just giving you here, dear students, vector form of Coulomb's force equation. A vector force on Q2, on charge Q2, charge here Q1 and Q2 are charges, on Q2 due to Q1 is, the vector force on charge Q2 due to Q1 is, I'm just denoting with F12 bar is equal to 1 by 4 pi epsilon naught Q1 Q2 by distance square R square. But here the distance, which is not just a distance, it is depending on displacement also. What is displacement here? R12 bar. If you know displacement, we can find distance. Magnitude of displacement is distance. So I must write R12, mod R12. Here I must write mod R12. Here mod R12 I should write. So mod R12, we need distance or distance square? Distance square. Coulomb's force is inverse square law. Yeah, mod R12 square. The direction of force is depending on unit vector. Any vector whose direction is assessed by unit vector along that vector. So unit vector is a vector. It is evaluated vector divided by its magnitude. So this is measured in Newton. How do you find A12 cap here? That you know, very basics. A12 cap is R12 bar divided by mod R12. That's all. Similarly, we can write a vector force on charge Q1 due to Q2 due to another charge Q2 is, I'm just giving a notation, F21 bar is equal to 1 by 4 pi epsilon naught Q1 Q2 by distance Distance doesn't matter, but displacement is very, very important. If you look at here, we are finding force on Q1 due to Q2. It depends on R21 bar. Then what is R21 bar? Its magnitude is giving us distance. So I can write mod R21 square direction of displacement is along the unit vector A21 cap Newton. So here, how can you find A21 cap? So where A21 cap is nothing but R21 bar divided by mod R21. So if you observe these two forces which are acting 180 degrees out of phase, yes, that is what we have Newton's law. For every force, there is a reactive force. So they differ by 180 degrees phase shift. If you just identify here, F12 bar is equal to minus F21 bar, or F21 bar is minus F12 bar. But their magnitude forces remains same. What is that? Mod F12 is equal to mod F21. How could you tell that? Yes, look at this equation. If you take magnitude of this rest is scalar quantity except this unit vector. If you look at this unit vector, what is the magnitude of unit vector? 1. The name itself, it has a meaning. Unit vector is a vector whose magnitude is always unity. If you take magnitude, what you are getting? Mod R12 square. Mod R12 square. Where mod R12 is equal to mod R21 because displacement doesn't have any direction. Yes. Then their magnitude forces remains same. Dear students, remember this is very important. When I have two objects, if I wish to find force on this object due to this object, we must draw the displacement towards this object. This is very, very important. That displacement direction will decide the direction of force, final direction of force, which is, if you observe here, this A12 cap here is decided by R12 cap or R12 bar. Similarly, here A21 cap, which you can take, so the A21 cap, if you wish to take the direction of force, which is depending on A21 cap. So A21 cap is depending on what? R21 bar. So here, if I wish to find force on Q2 due to Q1, we must take the arrow, tip of the arrow should be pointed towards that object Q2. If you wish to find force on Q1 due to Q2, the arrow must be towards Q1, object Q1. This will decide who is initial and who is final. For example, if I wish to find force on Q2 due to Q1, initial is Q1 location, final is Q2 location, final minus initial. This is important. Okay. Anyway, you can understand by just taking one example. I'll show you how to measure the force between the two objects. Dear students, here in this system or in this figure, if you look at, I have two objects. So each charge or each object is experiencing how many forces, dear students? Q2 is experiencing force due to Q1. Similarly, Q1 is experiencing force due to Q2. So each charge is experiencing one force. So when I consider system of two objects, each charge is experiencing one force. If I take one more charge here in this zone or in this region, Q1, Q2, Q3, then in that case, each charge is experiencing how many forces? Two forces. If I take four objects, each charge is experiencing 4 minus 1 forces, nothing but 3 forces. If I take n objects in the region, each charge is experiencing n minus 1 forces. If I wish to find resultant force on any one of the object is equal to vector sum of the forces due to individual objects. So in that situation, we can just take vector force between multiple n objects is equal to F1 bar plus F2 bar plus F3 bar plus and so on Fn minus 1. So this vector force is due to n minus 1 remaining n minus 1 object. This is like superposition principle. The response in any element is equal to algebraic sum of the responses due to individual elements, means the Coulomb's force equation which obeys superposition principle. Hence it is linear. Yes, if you wish to find resultant force, it is equivalent to vector sum of the forces. Okay. Dear student, this is about briefly about Coulomb's force equation, Coulomb's law and its mathematical model in vector form. Okay, yeah, once we know vector form, we can find magnitude whenever you want. Okay, I'm just giving you this example. I have shown already this problem earlier. Look at this. Find the vector force on minus 100 millicoulomb. Look at this. On a charge of minus 100 millicoulomb, on minus 100 millicoulomb, due 300. So the arrow must be pointed towards minus 100 millicoulomb. Yeah, I'm just giving you this data, whatever it is. Q1 is minus 100 millicoulomb at 0.2, 0, 5, and charge Q2 is at 300, it is 300 millicoulomb at Q1, 2, 3. The vector force on minus 100 millicoulomb due to 300 millicoulomb. I'm just showing here whatever the objects we have. These are the two objects we have, Q1 and Q2. Where Q1 and Q2 are located? Q1 is located at P2, 0, 5. There is another charge Q2 is located at point Q in spatial coordinates, which is 1, 2, 3. Where we wish to find force on Q1 on minus 100 millicoulomb. Then we must draw the displacement. I wish to find force on 100 millicoulomb due to Q2. Okay. Because of that, I have just taken arrow. This is a displacement. You need not put any suffix symbols. To avoid the confusion, I have just removed all those. Just put only R bar. Now using this, we can find, I'm just marking conventional direction of force, F bar. Okay. So what is our force equation? Before that, I'm just writing displacement. What is R bar here? Initial is Q, final is P. So what is that? Always you must take final minus initial. So what is that? 2 minus 1 AX cap plus 0 minus 2 AY cap plus 5 minus 3 AZ cap. This is the displacement drawn from Q to P. But you might have seen in your intermediate displacement from A to B, you might have taken OB minus OA, where OA and OB are position vectors of A and B. Here position vectors we need not take. Directly you can take P minus Q along with unit vectors. Then what is R bar here? AX cap minus 2 AY cap plus 2 AZ cap. So what is our Coulomb's force equation? Yes, I am writing here. F bar is equal to 1 by 4 pi epsilon naught Q1 Q2 by distance square mod R square A R cap. Just a skeleton of our equation I have given here, basic equation. What is 1 by 4 pi epsilon naught? We have a ready-made value 9 into 10 to the power of 9 Q1 minus 100 milli 10 to the power of minus 3. Dear students, take care while presenting the data on your answer booklet. Okay, so if minus sign is there, include the minus sign. Don't discard it, which is very important because we are not finding magnitude force. Here we are finding vector force. For that, sign plus or minus, which matters a lot, very important. What is Q2? 300 milli 10 to the power of minus 3. Yeah, before writing distance square, the simple way is write the displacement first. What is the displacement? We have taken already AX cap, yes, AX cap minus 2 AY cap plus 2 AZ cap. This is our displacement. What is basically here AR cap, dear students? AR cap is nothing but vector divided by its magnitude. Keep in mind, this is important, dear students. It is not just a vector. Unit vector is defined as vector divided by its magnitude. Then what we have? Divided by its magnitude. What is the magnitude of this? Square root of 2 square. I am just writing for your understanding. 1 square minus 2 whole square plus 2 square. Root 9. Root 9 is 3. Here we need root 9 whole square. Means 3 square. That's all. Yeah, I'm just giving you, for your understanding, one more step. We have minus sign. 9 multiplied with 10 power 9, 10 power minus 6, 10 power minus 3, 10 power minus 6. I can write comfortably here 10 to the power of 3. And from this we got how much? 1 from 100. I can write 10 square. And from here 300, I can write 3 into 10 square again. Okay, divided by 9, whatever is there here I am writing. Ax cap minus 2ay cap plus 2az cap divided by 3. Root 9, dear students. Square root of 4 plus 4, 8 plus 1, 9. Root 9 is equivalent to 3. I think if anything is cancelling, we can do it. 3 we can cancel. This 9 will be cancelled with this. Then 10 to the power of 3, 10 power 2, 10 power 2, 10 to the power of 7. I'm just keeping 110 here so that I can multiply with minus sign. I can also write minus 10 Ax cap. 10 power 6 I have taken out so that I can express my Coulomb's magnitude, Coulomb's force in meganewton. And whatever is left, 10 power 7, I have taken 10 into 10 to the power of 6. We are getting 10 power 7 from this, dear students. I am taking 10 into 10 to the power of 6. That 10 I am multiplying with this bracket along with minus sign. Then plus 20 ay cap minus 20 az cap. This is my force, final force equation. Meganewton. This is answer, dear students. How we got meganewton? 10 power 3, 10 power 2, 10 power 2, 10 power 7. I have taken 10 power 6 out. I can write mega 10 power 6. Rest 10 I am multiplying with this. That's all. This is your answer, dear students. Yeah, this is on Coulomb's force equation. One of the important area from electrostatics. Let us move to the next one, dear students. Electric field intensity. Basically, electric field intensity is measured with respect to Coulomb's force equation. Vector force field per unit charge is electric field intensity. I'm just writing the electric field intensity due to point charge. That equation, E bar due to point charge. E bar due to point charge Q Coulomb is given by electric field intensity E bar is equal to Q by 4 pi epsilon naught mod R square AR cap. Electric field is measured in, it is defined as basic definition, force per unit charge. Force is measured in Newton, charge is measured in Coulomb. So Newton per Coulomb, or there is a practical common unit we have, volt per meter. Electric field intensity is measured in Newton per Coulomb or volt per meter. This is due to one charge. I am just showing here for your understanding what we have here. This is our charge, Q Coulomb is located at some position from the origin. Let us take origin as a reference. With reference to origin, this is positioned at a position vector r1 bar. I wish to measure electric field intensity due to this object at some field point. Okay, then I must draw the displacement from the source to the field. Remember, dear students, this is a source where the charge is located. I can treat this as source point, SP. SP is the source point. This is a point I'm standing or I'm sitting here. I am measuring, I am observing the field. I can call this as observation point or field point. Field point is a point where I am measuring electric field intensity due to this object. So remember, always we must draw the displacement from source point to field point. So source point towards field point, this is my displacement r bar. Once we know r bar, we can find air cap. So evaluation of R bar is crucial here, dear students. How to take R bar? Displacement from source point to field point. How do you measure it? Very simple one I am giving. Displacement from source point to field point. Source point is initial point, field point is final point. So we must take FP final point minus initial point is our source point. This is very, very important, dear students. Once we know this, we can write AR cap. What is AR cap? R bar divided by mod R. That's all. This is common. Anywhere, if we take direction of any vector is assessed by unit vector, dear students. Yeah. This is due to one charge, monopole. But in the end, you may have discretized charges Q1, Q2, Q3 and so on, Qn. If there are n objects, then how do you measure electric field intensity? As electric field is defined with the help of Coulomb's force equation, as electric force or Coulomb's force is able to satisfy linearity property, hence electric field intensity also can satisfy linearity property. So from that, if there are n objects in the region, if you wish to find electric field intensity due to n objects will be vector sum of the fields due to individual objects, E1 bar plus E2 bar plus E3 bar plus and so on, En bar. What is E1 bar, dear students? Very simple. You just put a suffix. I don't want to write because those suffix symbols you need not remember. Directly you can write while solving the problem. That's all. So what you can write if you wish, E1, put suffix wherever you have. E1 bar equal to Q1 by 4 pi epsilon naught mod R1 square AR1 cap. That's all. Similarly, E2 bar, put suffix Q2. That's all. Q2 by 4 pi epsilon naught mod R2 square AR2 cap. So you just check carefully where the sources are given, which are called source points, and where you are observing, where you are sitting and where you are observing the electric field intensity or resultant field due to those sources. That is very, very important. Remember, always you must draw the displacement from source point to field point. That is very, very important. To understand this formula, I am just giving you an example which is one of the most important or commonly asking question from the electric field intensity from the various university exams. Okay? Yeah. I have 4 equal point charges of 3 nanocoulomb each are placed at P1, P2, P3 and P4. P1 is 110, P2 is -1, 1, 0 and P3 is -1, -1, 0. P4 is 1, -1, 0. Have you seen this is like quadrant, first quadrant, second, third, fourth. Also they can ask like if 4 equal point charges are located at the 4 corners of the square, they may ask us to find electric field intensity at any arbitrary point 1, 1, 1. They mentioned the medium is free space. What is the medium here? Free space means epsilon equal to epsilon naught. That you have to keep in mind. Except free space, any medium they have specified in the question, then you must take that only. Okay, that value you have to consider. Okay, I'm just writing the data here, presenting the data. Given data is very, very important, dear students. Any subject you take, whenever you are writing the examination, final examination or any examination, whether it is IES or mains or anything, you must be able to present the data correctly. That is important. Even if you do not know the solution, try to present the given data on your answer booklet. That data can give you an idea, that idea can give you answer directly. Yeah, that is very useful. Okay, Q1 3 nanocoulomb, Q2 3 nano, Q3 is 3 nano, Q4 is also 3 nano because they have mentioned it is equal charges. Then I must be able to calculate P, where I have to observe the field intensity at point P1, 1, 1. I'm just showing here. These are the source points, dear students. So I wish to find electric field intensity due to these objects at some field point P. The point P is 1, 1, 1. This for your understanding only I am drawing this. Okay, so what this diagram represents is, I'm just showing what is E1 bar, E2 bar, E3 bar. So where you are finding field intensity, this I can call it as field point. Dear students, field point. This is source point 1, source point 2, source point 3, source point 4. So due to every object you have to find the field. Wherever you are finding field intensity, you must draw the tip of the arrow towards that. So these are representing direction, conventional direction of our electric field intensities. So this arrow tip is representing, tip of the arrow is representing final point, other end of the arrow is representing initial point. So Fp minus P1, Fp minus P2, Fp minus P3, Fp minus P4. So using that, we can write our electric field intensity expression. Okay? Yeah, I'm just writing here the resultant field as a part of this solution. I'm giving you resultant electric field intensity. These, due to these four objects, E bar is equal to E1 bar. How many sources? There are four sources. Then we must take E1 bar plus E2 bar plus E3 bar plus E4 bar. Dear students, you need not write the formula. I'm just writing the formula for one charge, basic formula. E bar is equal to Q by 4 pi epsilon naught, since the medium is free space, mod R square, and direction of field is AR cap. Okay, you need not write individual formula. Directly you can write your equation. I'm just writing here E bar is equal to, in all these, who is common? 1 by 4 pi epsilon naught. Is it right? And if you look at all the charges are having same magnitude or not, same polarity, can we take it common? Yes, we can bring it out. And rest is direction and magnitude square. That's all, distance square. So we should know the displacement for each one. This I'm showing here field point. What is a field point, dear students? Here field point they have given, I'm just writing here 1 comma 1 comma 1, all are having positive sign. 1 comma 1 comma 1. So Fp minus Sp. First one you tell me 1 minus 1 0, 1 minus 1 0, z component 1 minus 0. So Az cap simply. Next one 1 minus of minus 1. Like that we have to take Fp minus Sp. I'm just writing 1 by 4 pi epsilon naught. What is that value, dear students? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. So we can take that value directly as a common factor. Also, all the charges are having same magnitude. I can take that also out. What is that? 3 nanocoulomb. So 3 into 10 to the power of minus 9. The rest I am writing inside for every object. It depends on displacement. So before writing distance square, I am writing displacement first. For the first object, what is the displacement? Yeah, 1 minus 1, 1 minus 1, 1 minus 0, which is z vector Az cap divided by magnitude is 1. Remember, dear students, whenever you are writing AR cap, it is vector by magnitude. Don't forget it. If you skip that, that idea will give you wrong answer. Take care, dear students. Yeah, what is this here? Distance square, 1 square. Skeleton, 1 by R square into AR cap. That is a basic equation. Next, plus 1 by distance square. Before that, I am writing displacement. If you write displacement, it will become easy for you, dear students. Yeah, what is the displacement for the second object? 1 minus of minus 1, 2, 1 minus 1, 0, 1 minus 0. So what you are getting? 2Ax cap plus Az cap divided by its magnitude, dear students. Root 2 square plus 1 square, square root of 5. And this one is root 5 whole square. This is for the second object. Look at for the third object. Yeah, 1 by distance square. Yeah, third one. So what is the third one? 1, 1, 1 is a final point. 1 minus of 1, minus 1, 2. 1 minus of minus 1 again 2. And 1 minus 0, it is 1. Look at x component, y component, z component. So 2ax cap plus 2ay cap plus az cap. Yes, it is 2 ax cap plus 2 ay cap plus az cap, dear students, divided by magnitude square root of 2 square plus 2 square plus 1 square, root 9. Root 9 is how much? 3. I need distance square, 3 square. This is for third object. Next, fourth object. Look at the fourth object, 1, 1, 1 minus 1 minus 1, 0. 1 minus 1, 0. 1 minus of minus 1, 2. 1 minus 0 it is. So what we have here, 1 by distance square, it is 2 ay cap plus az cap divided by root 5 and distance square, square root of 5 whole square. This is our equation, basic equation from the formula we have taken. Now you can simplify this, rest you can write by having common factors if any. This is 9 into 3, 27, dear students. 10 power 9, 10 power minus 10, 10 power 0, we can write 1. That we need not write. In fact, whatever is left, I am writing x, y, z sequentially. So I am just writing at one place 2ax cap divided by 5 root 5, this one. And any x you can write. And another one is we have 2ax cap divided by 27, dear students. Look at this, 3 square into 3, 9 into 3 it is 27 plus any other x components, nothing. Now we can write a, y components, yes, 2 ay cap divided by 27 again plus any other y component. Yes, here we have 2 ay cap divided by 5 root 5. Dear students, we have root 5 whole square. Don't forget to take that. This also we must multiply. 5 root 5. Next, z components, you write az cap. This is az cap. The remaining we can write az cap divided by 5 root 5 plus, what is here? Az cap divided by 27. Any other? Yes, here also we have another az cap. Az cap divided by 5 root 5. 5 root 5. That's all. This is our equation. Just simplifying. By simplifying these, you will be getting all three components. I am just writing the answer directly from this simplification. If you look at these, x and y look same. Yes, they have same magnitude except it is x cap and that one is ay cap. So we'll be getting approximately around 6.83 x cap plus this also will be same y component 6.83 ay cap. After multiplying, dear students, don't forget to multiply with 27. After simplifying these, you should multiply with 27. After that, I am writing final answer. Plus last one, I think 32.83 az cap, where units of electric field, volt per meter. This is your answer, dear students. You can also verify from your calculation part. You know how to calculate. Using your calculator, you check. If any discrepancy, you can tell me. So 6.83 x cap plus 6.83 ay cap plus 32.83 az cap. This is your final answer, dear students. Resultant field, which is projected along x, y, z three-dimensionally, the field distribution. Yeah, this is one of the important area. We have taken multiple objects or discretized charges. We calculated resultant electric field is a vector sum of the fields due to individual objects. Yeah, the next one, which is one of the important area from electrostatics, Gauss Law. Who stated Gauss Law basically, dear students? Gauss Law was stated by Michael Faraday, not by Gauss. But why they have given the name? Michael Faraday was very poor in mathematics. He took the help of one of the great mathematicians in the world, Carl Friedrich Gauss, his name. He put lot of efforts, whatever the concepts or the experimental results after giving Michael Faraday, who was a French army engineer, who worked as director of Royal Society of London. He started his research with static fields. In his early research, one of his experiments made us very simple analysis of electrostatic fields, which makes it very simple. Because if you go directly evaluation of Coulomb's force equation, it may take 3 pages or 4 pages to compute electric field due to charge distributions rather than discrete charges. So in such a cases, we can use Gauss law. Using that, we can simplify the analysis of electrostatic field. So Gauss law, which is stated by Michael Faraday, not by Gauss. Because of his great contribution, mathematician Gauss' contribution towards Michael Faraday's experiment, he was given the credit to mathematician Gauss. So Gauss law states that the net electric flux leaving any closed surface is equal to total charge enclosed by that surface. Here the very important word is closed surface. The net electric flux leaving any closed surface is equal to total charge enclosed by that surface. So mathematical model of Gauss law I am giving you here. The net flux psi net is equal to charge enclosed is equal to closed surface integral d bar dot ds bar is equal to, using divergence theorem, I can convert closed surface integral into volume integral. I can write volume integral del dot d bar dv. And from Gauss law mathematical model, this del dot d bar equal to rho v. We can write this is volume integral rho v dv. Dear students, observe the symbols, they are very important, you can't neglect, especially in integrals. You look at here, psi net equal to charge enclosed. This is a basic model given by Michael Faraday, Faraday's law. The net electric flux leaving equal to charge enclosed. According to Michael Faraday's experiment, flux is carrying the units of charge which is measured in Coulomb. And where d bar, whatever I've written, electric flux density or displacement flux density, which is measured in Coulomb per meter square. This is measured in Coulomb. We know charge is measured in Coulomb, and d bar is electric flux density. Charge or flux per area, flux density. Area is measured in meter square. So flux is measured in Coulomb and area is measured in meter square. Then the displacement flux density is measured Coulomb per meter square. And from the divergence theorem converts closed surface integral into volume integral or vice versa. Volume integral into closed surface integral. So from that we can write volume integral del dot d bar dv. Look at these two integrals, dear students. This is closed surface. Whenever we are writing s at the bottom, it is a surface integral. Whenever we are talking about surface integral, it should be double integral. Dear students, if you observe here, whenever you are writing surface integral must be double integral. It is evaluated over a closed surface. That is the meaning of this integral. D bar dot ds bar. Look at the other integral, VOL, that indicates volume integral. Volume is a product of 3 variables. Whenever you have 3 variables in integration, that should be triple integral, should take care of it. Also, we have written del dot d bar equal to rho v. This is generally called differential form of Gauss law. Del dot d bar is equal to rho v. Dear student, this is one of the Maxwell's equation given by James Clerk Maxwell. Del dot d bar equal to rho v. From the divergence property we can have, at the end I'll give you conclusion of Maxwell's equation. By substituting rho v here, I can write the Gauss law in full form. ఎందుకని ఇక్కడ ఆఫ్ అయితే ఆన్ అయింది అలా ఎప్పుడైంది? ఇప్పుడేనా? ఇంతకుముందు ఇప్పటివరకు బాగానే వచ్చిందా? ఓకే. ఇక్కడ అక్కడ మరి ఎలా ఇప్పుడు ఓకేనా? ఎంత టైం? ఓ 1 hour అయిపోయిందా? ఏది అచ్చా ఇక్కడే నాకు తెలిసి ఇప్పుడే పోయిందన్నావుగా. జస్ట్ ఫ్యూ మినిట్స్, ఫ్యూ సెకండ్స్. ఇక్కడ బ్యాక్ వెళ్ళినా ఇక్కడే ఇదే స్టార్ట్. ఆల్మోస్ట్ 10 minutes అయింది స్టార్ట్ చేసి, 10-15. ఓకే. మిగతాదంతా బాగానే వచ్చింది కదా? ఓకే ఓకే. Dear students, I am just giving you summary of this Gauss law. Gauss law states that the net electric flux leaving any closed surface is equal to total charge enclosed by that surface. So if you observe here, there are various models or problems they can put on this concept. They can give on this concept. Net flux equal to charge enclosed just by giving charge configurations either Q1, Q2, Q3, rho L1, rho L2, rho L3, rho S1, rho S2, rho S3 or volume charge configuration. They'll ask us to find what is the net flux leaving. Check carefully whether the charges lie within the boundary which is called Gaussian surface or not. If they lie within the boundary, then we can take directly psi net equal to charge enclosed is total charge contained within that region. Okay, I'm just giving you this model. If you observe here, there are three objects. Say Q1 is 3 nanocoulomb, Q2 is 5 nanocoulomb, Q3 is minus 8 nanocoulomb. If they asked us to find what is the net flux leaving this region, surface S1. The net electric flux leaving the surface S1, psi net is equal to charge enclosed. Treat this as a Gaussian surface. According to Gauss law, the net electric flux leaving equal to total charge enclosed by that surface. What is that? Q1 plus Q2 plus Q3. Are they lie within the boundary or not? That you have to take care. So all lie within the boundary. 3 plus 5 minus 8. How much? It is 0 because this is having negative polarity. On the other hand, if I just give another surface, if I wish to calculate the net electric flux leaving the surface S2, how much, dear students? The net electric flux leaving is nothing but total charge enclosed, then psi net is equal to charge enclosed, charges which are lie within the boundary, Q1 and Q2 only. How much? 5 plus 3, this 8 nanocoulomb is the answer. Like that we have to check carefully. Okay? Instead, they can give rho L, rho S, rho V. If line charge configurations are given rather than point charges, say rho L1, rho L2, rho L3. Dear students, if they're given like this, don't add rho L1, rho L2, rho L3, which is very bad. So we should not add directly, because Gauss law which we have, net electric flux leaving equal to charge enclosed. In terms of Q we have, in terms of charge densities we don't have. So what you have to do, convert rho L into Q. We know that Q equal to rho L into length if the charge configuration is uniform. If it is non-uniform, you can measure by taking line integral rho L dl. Remember this, dear students. Okay, yeah. So now, this is one model. Or by giving d bar, they'll ask us to compute what is the net flux leaving the region bounded by a cube or a cylinder or a sphere. Anything they can give. I'll give you that example later. Or else, the same you can solve by using divergence theorem. The beauty of divergence theorem is, if you solve by direct method, For example, d bar is given in Cartesian. They're asking us to compute what is the net electric flux leaving a cube or a cuboid. Cube means all dimensions are equal. Cuboid, they doesn't have equal dimensions. Then, if you use this surface integral method, you may need 3 pages because there a cube or a cuboid is having how many surfaces? 6 surfaces. You have to calculate flux leaving each surface. So psi 1 plus psi 2 plus psi 3 plus psi 4 plus psi 5 plus psi 6 is the resultant flux. So means at any cost you have to evaluate 6 integrals, which becomes a laborious process. I don't suggest that method if we are preparing for any competitive exam. If it is university examination, you can use that method or you can use this method. This is quite simple. Del dot d bar rho v dv. So what is that? Use the divergence theorem, then you can get the answer within 3 lines. That is the beauty of divergence theorem or Gauss divergence theorem. Sometimes they may give rho v, they ask us to compute psi net or q enclosed. And another one, dear students, this is another important formula. By using this, you can compute volume charge density for the given electric flux density. For the given electric flux density. I'll give you that example later. Now, before that, using this mathematical model, we can also calculate d bar and e bar by a simple analysis. That is another advantage of Gauss law. If you go by direct method of evaluation, then it may take around 2 to 3 pages to calculate electric field due to line charge, surface charge and volume charge configurations. If we could use Gauss law mathematical model, within 2-3 lines you will get the answer. See how much time we can save, that analysis complexity can be reduced by using Gauss law. That is how this is more popular mathematical model in electromagnetics. Yeah, I'm just giving you one example here to compute electric field intensity due to, this is a question they asked in various universities. All are having the same solution. Look at the first one. Using Gauss law, obtain an expression for electric field intensity due to infinitely long wire with uniform charge density rho L. Uniform means charge density is same everywhere on the line. If charge density is different at different points, then the charge distribution is called non-uniform. Yeah. Anyway, they have given uniform charge distribution. Using Gauss law, find E at any point due to long infinite charged wire. Same question, dear students. Another university they asked like this. Derive the expression for electric field intensity due to uniform line charge. This is also same as the first one asked in another university. I have just collected from the various universities. I have just presented here how they are asking question. You should not confuse in the exam hall. You should not have that. You should have an idea how they are giving questions on various concepts. That is very important. Further, you need lot of practice, dear students. Not only attending classes, if you are able to practice different previous paper questions, then you will understand. Definitely I am here to help you or guide you to give whatever the presentation on, whatever the different questions they are asking on multiple concepts. Okay? Yeah. I am just giving you how to present the solution for this. Using Gauss law we are doing. How simple it is, look at here. Now when we are applying Gauss law mathematical model, should take care, the very first step is, I am just giving you this simple mathematical equation to apply Gauss law. Qn closed is equal to dn multiplied with area. Whatever the basic equation I have, that is the equation. What is that? Qn closed equal to closed surface integral d bar dot ds bar. This is our basic equation. According to Michael Faraday's analysis, in his experiment, no flux was found tangential to the surface. That is a conclusion from the Michael Faraday. And he was shown from his experiment, no flux is present tangential to the surface. Hence, he was taken directly normal component. Look at this, dn stands for normal component of flux density. Qn closed is nothing but charge enclosed by the Gaussian surface. That is the reason why in my integration formula, if I know the standard configurations like cylinder, cube, cuboid, sphere, I don't want to use integration method. I can use the simple method if the flux density is uniform or charge configuration is uniform. So in that case, I have just represented this formula in this fashion. So what is this ds? Area. If my component is known, if you observe this, this is dn cos theta is 1, then dn ds. I am just having dn into ds. I have the component, I just integrate. If I integrate, what is this? Let us take differential amount of charge enclosed. If I integrate, integral of this, q enclosed will be, dn is constant anyway, integral of ds is what? S. What is S? Area. That I have written here. That's all. For everything we have mathematical proof. You need not worry about it. Okay? That is the beauty of mathematics. This is charge enclosed. When we are applying Gauss law, this ready-made formula you can use, dear students. Yeah. Whenever you are applying Gauss law, remember students, the very first step is select the suitable imaginary closed surface to which Gauss law can be applied. That closed surface is generally called Gaussian surface. Gaussian surface. For that, once we have selected Gaussian surface, identify the components of flux density by which it is contributing non-zero flux. So tangential components doesn't contribute flux. Flux due to tangential components will be 0. Only normal components can contribute from the Michael Faraday's conclusion. Once we have decided the components, calculate the charge enclosed by the Gaussian surface. Charge enclosed is nothing but charge contained by the source. Area. Area is nothing but area of the region at which you are finding flux density. Very, very important. Area of the region. What kind of area it is? What kind of area? Net flux leaving any closed surface. Gaussian surface is closed surface. What are the examples of closed surface? Cube, cuboid, cylinder, sphere, cone. All these are closed surface regions. So we must select the area of the region where you are finding flux density. Flux density, yeah. So while selecting Gaussian surface, you must take care. Suppose you have point charge. Point charge is like what? Point charge is like a point sphere, little sphere, very cute sphere we have. Point charge is like a point sphere. Then whenever you are selecting Gaussian surface to this, if you wish to find electric field intensity or flux density due to this charge, how it looks, this is like a sphere. Then select the suitable imaginary closed surface to which Gauss law can be applied. That surface is spherical surface. That is how we have to select. Suppose you have a wire. I have a wire, charged wire with me. I wish to find electric field intensity due to this at any point in the space. How wire looks? The wire is looking like your pen or a refill inside. It looks like what? It has a cylindrical symmetry. Then what is a suitable surface we can choose for a line? Cylinder. Similarly, we have volume charge cloud. Then what is a suitable surface? Spherical surface. So like that, if you have a sheet, a rectangular sheet, I wish to find electric field intensity or electric flux density due to sheet, then what is a suitable surface we can choose? Cube or a box or a cube structure, anything we can choose. So that is how we have to select the suitable imaginary closed surface. Yeah. Now I am just giving you here one example how to use Gauss law mathematical model to calculate electric field intensity due to infinite line or charged wire. Look at this. Dear students, whatever the yellow color one, which is our line. The line which is charged wire or charged line, which contains charge distribution, uniform charge density rho L Coulomb per meter. Then I wish to find electric field intensity or flux density at any point in the space. Then what symmetry the line has? As the line is having cylindrical shape, cylindrical symmetry, select the suitable imaginary closed surface to which Gauss law can be applied. I have taken a blue color one, which is the imaginary cylinder. Why cylinder, dear students? Because my charged wire is having cylindrical symmetry. That is the reason. So this is my Gaussian surface. This is the point where I wish to find electric field intensity at a point at this distance. This is the point where I am observing d bar, or I can find E bar, electric flux density or electric field intensity. Once we know electric field, we can find electric flux density, or if we know any one of them, we can find other one. And the height of the cylinder I have taken L, or length of the cylinder is L. This is the point where at a radial distance rho, I wish to find flux density or field intensity. Do we have same distance everywhere on the surface of the cylinder? Obviously, it is a cylinder. It has a radial distance from the z-axis everywhere. It is same length rho. If you have taken rho 1 only. If you have taken 5 centimeters, it is at 5 centimeters only. We have taken a charged wire along z-axis. Do we have any field tangential to this? No field tangential to this means along top of the cylinder dz is 0. Bottom of the cylinder dz is also 0. And d phi is anyway 0 because phi and z are tangential to the cylinder. Who is non-zero in this case? D rho, which is perpendicular to the wire or the source or a cylindrical surface. D rho, which is contributing non-zero flux density. Non-zero flux density. So we have d rho, which is non-zero. D rho is not equal to 0. So except dz and d phi, only d rho is contributing non-zero component, which is perpendicular to the cylinder. That I have told earlier. No flux was found tangential to the source or tangential to the surface means dz along top. Look at the cylinder, how many surfaces it has? Top surface, bottom surface and side surface. Do we have any flux along top? No, because along top it is z component, bottom also z component, dz top, dz bottom both are 0, only side. Side is what? Cylinder. So d rho is not equal to 0. Okay? Yeah, what is our Gauss law? Q enclosed, the simplified one, is equal to dn into area. Dn multiplied with area. What is a charge enclosed by the Gaussian surface? Look at the Gaussian surface. Charge enclosed is nothing but charge contained by the source. Dear students, is it a point charge or is it a line or sheet or volume charge? No doubt in that it is a line charge. Whenever they have given line charge, how did you find line charge density? Rho L is charged by length. I want total charge, Q enclosed. What is Q enclosed? Q enclosed is equal to rho L into length. What is that? Rho L multiplied with length. Rho L multiplied with length, what is that? So we have rho L into length, L is equal to charge contained by this. dn, which component of d is contributing non-zero flux? D rho, d phi is 0, dz is 0. Area of the region at which we are finding flux density. Dear students, you should take care while choosing this area. At what distance you are finding flux density? At the distance rho. With this distance rho, what you are forming? Is it a circle or a cylinder? We have a cylinder. What is the area of the cylinder? We have a cylinder of radius r. Height of the cylinder is h. Then, what is the area of cylinder? 2 pi r h. What is the volume? Pi r square h. Then, what is the area? 2 pi r. What is r here? Rho. What is L or length or height of the cylinder? L. That's all. Now, look at this. This L we can cancel. Then d rho I can write rho L by 2 pi rho. Once we know this, we can write, therefore, electric flux density due to infinitely long charged wire d rho a rho cap is equal to rho L by 2 pi rho a rho cap, Coulomb per meter square. Once we know this, how to find electric field? What is electric field intensity? Relation between electric field intensity and electric flux density. D bar equal to epsilon E bar. Then I need E bar. E bar is D bar by epsilon. Then I can write D bar by epsilon is equal to rho L by 2 pi epsilon rho a rho cap volt per meter. Look at this, within 3 lines we got this expression. But if you use direct method using Coulomb's law, it may take minimum 2 pages to 3 pages. Yes, that is the beauty of Gauss law mathematical model. Now, we got the expression for electric field intensity due to infinitely long wire. E bar is equal to, again I am writing, dear students, E bar is equal to rho L by 2 pi epsilon rho A rho cap. This is a direct expression you can use if you are evaluating electric field in cylindrical coordinate system. Should take care. This is the expression, ready-made formula you can use directly in cylindrical coordinate system. But in the exam, most of the times they are asking question on electric field evaluation due to line in Cartesian domain. So for that I am giving you a ready-made formula in Cartesian. If you wish to measure electric field intensity due to line, I can write E bar is equal to, it looks same, no change, only I'm just changing the symbol, 2 pi epsilon r or mod r AR cap. This is a formula you can use while finding electric field directly in Cartesian. Rho L 2 pi epsilon r. What is r here? Magnitude or distance, where rho is perpendicular distance. Similarly, r is perpendicular distance. Yeah, look at this in the figure. Rho is always in cylindrical coordinate system. Rho is always perpendicular distance measured from its axis. So at any cost, while evaluating electric field due to infinite line, we should have perpendicular distance. So for that I have shown R generalization. And you know anyway AR cap, what is AR cap? That you know, R bar divided by mod R, displacement by distance. Okay, yeah. So R bar is what, dear students? Displacement from SP to FP. Here source point coordinates must be selected with respect to field point. So SP, source point coordinates, can be evaluated by dropping foot of perpendicular from field point onto the source point. Don't worry about this terminology, dear students. I'll explain you while solving the problem how to choose it in a very simple manner. So at any cost, while finding electric field intensity due to infinite line, we must select displacement from SP to FP. While selecting SP, why we need to select SP, source point coordinates? Will they not give? They will give in the question. But a line is represented by only two coordinates. Intersection of two constant surfaces results a line. Other coordinate will be missing. That missing coordinate is depending on field point. I'll show you in our example. In problem, directly I'll explain you how to choose it. Yeah. Dear students, I've given one example here, which is one of the important model. Even this same model, the same question they asked in IAS Engineering Service Examination also. Look at the question. An infinitely long uniform line charge is located at y equal to 3, z equal to 5, and rho L is given charge density 30 nanocoulomb per meter. Then what they are asking us to find electric field at 0, 6, 1, and there is another point 5, 6, 1. Okay? Yeah. So what I've told, when you have a line, a charged wire like this is our line. I wish to find electric field intensity at some field point. This is my field point. Whenever you have field point, look like this. If you are evaluating electric field, at any cost you have to establish perpendicular distance, dear students. In the exam you need not draw with scale, nothing is required. This diagram is also not required. Just for your understanding I am showing. Because electric field due to line is depending on rho. Look at this equation. That rho we have taken as R. So at any cost you must be able to establish perpendicular distance. So for that I have drawn this. If you have taken this combination, this is wrong. This is absolutely wrong combination. That is why we should not take. Okay, yeah. So this is a source point. We have a source point coordinates. Source point coordinates will be given only 2 because line is represented by 2 coordinates. So if any coordinate is missing, that missing will be depending on how the line is represented. Look at this, y equal to constant, z equal to constant. Our line is described by 2 coordinates, y coordinate, z coordinate. Definitely who is missing here, dear students? Very simple way how to identify. whether this line is parallel to x-axis or y-axis or z-axis. Whatever the coordinate is missing, the given line is parallel to that missing coordinate. Who is missing here? We are studying about three-dimensional coordinate system, x, y, z. Line is defined by y and z. Who is missing here? X. Definitely your line is parallel to x-axis, no doubt in that. If you draw it from the geometry, you will get that only. Okay? You need not draw. It is all waste of time. Without drawing any diagram, you can solve directly, you will get the full marks. No doubt in that. So y is constant, z is constant, your line is parallel to x-axis. If the given line is parallel to x-axis, how do you represent the coordinates here is y equal to constant, y equal to 3, z equal to 5. The given line is parallel to x. However, line is infinitely long wire. Along x-axis, the value of x can be taken anything from minus infinity to plus infinity. But who will decide whether it is minus infinity or plus infinity or minus 1 lakh or 10 lakh or minus 100, minus 1000? Who will decide? Field point only will decide. Yes. Look at one of the field point they have given 0, 6, 1. Whichever the coordinate or whoever the coordinate is missing, that missing coordinate you can drop towards source point. That is what I have told. Source point coordinates. This is a source point. This is my SP, source point. SP can be evaluated or source point coordinates can be obtained by dropping foot of perpendicular from field point onto the source point. Very simple. Whoever is missing, that missing coordinate you can get it from field point itself. I am just giving you another example for your understanding. Suppose we have a line. Line is described by x equal to 2, z equal to minus 4, dear students. Now can you tell me this line is parallel to whom? Very simple. X is constant, z is constant. Who is missing here? Y is missing. Definitely your line is parallel to y-axis. No doubt in that. Even if you draw, you will get it. Not required. Suppose in this problem, I wish to find, I'm asking you to find E bar at 1, 3, 5. Now tell me, what is a field point, dear students? What is a field point in this example? 1, 3, 5. What is a source point, dear students? X is constant, Z is constant, minus 4. Who is missing? Y. Y is missing. Definitely the line is parallel to y-axis. Who is missing here? That missing coordinate you can extract by dropping from field point onto the source point. Now from this you can get the new coordinates of source point 2, 3, minus 4. Don't disturb other. Only y, whoever is missing. Now if you know this, can you find displacement? Yes. How do you get the displacement? Displacement always you should take from SP to FP. SP to FP means arrow must be pointed towards that field point. This is R bar. Now you tell me, dear students, who is initial and who is final? Tip of the arrow is indicating final, other end of the arrow is indicating initial. So always R bar is FP minus SP. That's all. You have another combination, say for example, just giving you another one, say x equal to 5, y equal to 6. This is a line. Can you tell me, dear students, this line is parallel to whom? This line is parallel to what? Parallel to? Who is missing? Z is missing. Your line is parallel to Z axis. That's all. If I asked you to find E bar at 1, 4, 3, then how to choose these missing coordinates? Look at here. FP is 1, 4, 3. SP is x is constant, y is constant. Who is missing? Z. How do you get the Z? Yes. That missing coordinate you can extract by dropping of perpendicular from field point onto the source point. Then what are the new coordinates, dear students? 5, 6, 3. Once we know this, we can find displacement. I have just given 3 different examples how to choose it. Now with this information, I am giving you this problem, how to solve it. Now tell me, what are the new coordinates? What is the field point? 0, 6, 1. First bit, if I solve the first one, what is the first one? Field point is 0, 6, 1. Now what is your source point? Y is constant, Z is constant, X is missing. The new coordinates of source point you can find by dropping this 0, 3, 5. Okay, yeah. Once we know this, I'm just giving you FP is 0, 6, 1, SP is 0, 3, 5. After dropping, put off perpendicular from field point onto the source point. Then we can find displacement, dear students. Tell me what is the displacement? R bar. What is R bar? FP minus SP. 0 minus 0, 0. 6 minus 3, 3. AY cap. 1 minus 5 minus 4 AZ cap. Once we know this, dear students, what is R? Square root of 3 square plus minus 4 whole square. Root 25, I think. Root of 16 plus 9 plus 16. Root 25, it is 5 distance. Now we have rho L with us and we can find electric field intensity. What is electric field intensity? Yes. E bar is equal to rho L by 2 pi epsilon naught mod R AR cap. This is our equation. We know that. I have given this formula already. Dear students, you tell me we have 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9. Now I need 1 by 2 pi epsilon naught is equal to how much? 1 by 4, 1 by 2. It is twice. Twice means 2 times of this. It is 18 into 10 to the power of 9. This ready-made value you can use. Okay? Yeah. So what is that? I am writing here. So E bar is equal to 18 into 10 to the power of 9. Rho L is given 30 nano, 30 into 10 to the power of minus 9. This is rho L. And we have distance. Distance is how much? 5. We have calculated, dear students. Look at back. R is 5. And R bar also we know. I am writing here. 3 AY cap minus 4 AZ cap divided by 5. 10 power 9, 10 to the power of minus 9 is 10 power 0. Whatever is left, I am writing 18 into 30 divided by 25. So after simplifying this, you may get, therefore E bar, you just verify this calculation, dear students. You may get around 64.7 AY cap minus 86.4 AZ cap volt per meter. This is your answer, dear students. You can verify using your calculator. Okay. Yeah, this is for a first bit. Look at, dear students, second one. Will you get the same or not? Yes. Why? Look at 0, 6, 1. This point is 5, 6, 1. I am just showing here itself. What is the field point? Second bit. I am just showing you verify this calculation later, dear students. FP is 5, 6, 1. What is my source point? Same source, same location. I am not changing at all. X, 3, 5. Y equal to 3, Z equal to 5. Now who is missing here? X is missing. How do you get X coordinates? By dropping foot of perpendicular from field point onto the source point. Dear students, tell me what are the new coordinates we can get? 5, 3, 5. So how do you get displacement? R bar. Tell me, dear students, what is R bar? Will you get the same as previous one or not? Check it. 5 minus 5, 0. 6 minus 3, 3 AY cap. 1 minus 5, minus 4 AZ cap. So what is R bar here? 3 AY cap minus 4 AZ cap. Will you get the same or not? Yes, it is same. So why it is not changing? Look at, as the given line is parallel to x-axis, the resultant field is independent on x coordinates. Independent on x coordinates. It will depends on whom? Y and z coordinates. Look at 1 and 2 bits. First bit y and z coordinates 6, 1. Second bit also 6, 1. There is no change in y and z coordinates. Until unless there is no change in y and z coordinates, your answer is same. Because there is no change in displacement. When no change in displacement for the same charge configuration, you will get the same answer. So, answer for the second one also 64.7 AY cap minus 86.4 AZ cap. No change. Similarly, dear students, you have to observe one important thing here. If the given line is parallel to x-axis, the resultant field is independent on x coordinates. It will depends on what? Y and z coordinates. If I give third bit is 100, 6, 1. What is the answer? Same, no change. Fourth bit is 1000, 6, 1. Same. 1 lakh, 6, 1. Your answer is same. Because it is independent on x coordinates. That is the reason why electric field intensity at 0, 6, 1 and 5, 6, 1 will be same. On this, they asked question in ESC exam. If electric field intensity in engineering service examination, they asked, if the electric field intensity at 0, 6, 1 is 64.7 AY cap minus 86.4 AZ cap, then what is electric field intensity at 5, 6, 1? That is the question they asked. Without putting pen on the paper, you can directly pick up the answer. Yeah, that is based on the concept. Let us move to the next question, dear students. It is on sheet charge distribution. You might have heard electric field due to infinite sheet. I am just giving you here the formula. E bar due to infinite sheet. This also you can calculate using Gauss Law, application of Gauss Law. Due to infinite sheet, electric field intensity due to infinite sheet with uniform charge density rho s, Coulomb per meter square, where rho s is charge density, which is surface charge density, defined as charge per unit area. Due to infinite sheet with charge density rho s is given by E bar is equal to rho s by 2 epsilon naught or epsilon, anything. If medium is free space, you can take epsilon naught plus or minus an cap. This is a formula, dear students. Directly you will get the problems on this formula in your exam, final examination. What is an cap, dear students, here? An cap is unit vector normal to the plane. I am just writing for your understanding, where an cap is unit vector normal to the plane, unit vector normal to the plane in which sheet is located, How to choose this? Very simple, dear students. From the basics of coordinate systems you can choose. I'll tell you anyway. If the sheet is located in x equal to constant plane, an cap is ax cap. If the sheet is located in y equal to constant plane, then an cap is ay cap. If the given sheet is located in z equal to constant plane, then an cap is az cap. Whoever is constant, that suffix will come. Suppose you have x constant, ax cap will come. Your sheet is located in y constant, ay cap will come. If the sheet is located in z constant, az cap will come. This is for, I am just writing for your understanding, x constant, and this is for y constant, and this is for z constant. That's all. But what about plus or minus, sir? Yes, very simple. Whether you are finding field above the sheet or below the sheet. if you are finding field above the sheet, then plus sign. If the field is below the sheet, then minus, that's all. Above and below in mathematics, how to choose? That is the beauty of mathematics. Above and below for comparison are done by greater than, less than and equality. So, if field point is, I am just writing, that is for your understanding. If FP, dear students, what is FP here? Field point greater than source point. If field point is greater than source point, then plus AN cap, that's all. Another case what we have, if field point is less than source point, then minus AN cap. This is very important, dear students. Greater than means, what do you mean by that? You are finding field above the source. FP is field point, SP is source point. If you are finding field below the sheet, then minus sign. On this I am giving you one example, dear students. Look at, this is one of the important model. These models they are asked even in ISRO exam, in competitive exam, and even in ESC exams also, and even in our university examination, one of the university examination they asked this question, same question, I have taken it. We have 4 sheets, dear students. 4 infinite sheets with uniform surface charge densities are located as follows. 20 picocoulomb per meter square at y equal to 7, minus 8 picocoulomb per meter square at y equal to 3, 6 picocoulomb per meter square at y equal to minus 1 and minus 18 picocoulomb per meter square at y equal to minus 4. Calculate electric field at A, point A, 2, 6, minus 4, point B, minus 1, minus 2, 1.5. Dear students, they can give anywhere, whatever it is. Okay, look at where the sources are located. That is a very, very first important point you have to observe from the given data. So, where the source is located here in this example, y equal to 7, another source, y equal to 3, y equal to minus 1, y equal to minus 4. Fortunately, in this example, they have given all the sources are at y equal to constant. Sometimes in the exam, this can be y equal to 7, it may be x equal to 5, it may be z equal to 6, like that they have given different, they will give different constant surfaces. Don't worry about it. Check carefully where the sheets are located. Dear students, if the sheet is located in x equal to constant, concentrate on x constant surfaces. If the sheet is located in y equal to constant surface, concentrate on y coordinates in the given data, means in field point. If the sheets are located in z equal to constant plane, then your concentration should be on z coordinates, because these coordinate values will not give any magnitude, will not have any impact on magnitude. Look at the magnitude equation. Rho s by 2 epsilon. Any coordinate here? No. No distance, nothing. But what is the purpose of coordinates in the field point? To decide the sign of AN cap. So whether your field is above or below or greater than or less than, to decide that only we need coordinates. Yes. Now in this example, where the sheets are located? Sheets are located at y equal to constant. That is the reason why you focus only on y coordinates in these 2 examples. That's all. That is enough. I'll explain you anyway how to solve it. Yeah. So look at this solution we have. Now look at the given data. Let this is rho s1 and this is rho s2, rho s3, rho s4. There are 4 sheets, dear students, having their magnitudes. All are y equal to constant. I wish to find electric field due to these 2 sources. Now what is our expression? Electric field due to 4 sources, E bar equal to E1 bar plus E2 bar plus E3 bar plus E4 bar. What is the expression? Magnitude rho s by 2 epsilon. What is AN cap, dear students, in this example? What is AN cap? How to choose AN cap? It may be plus or minus AY cap. No doubt in it. Plus or minus AN cap is plus or minus AY cap. Why? Sheets are located in y equal to constant. Whoever is constant, that suffix will come. If y constant, suffix y will come. Z constant, suffix z will come. X constant, suffix x will come. Okay, yeah. I'm just giving you the equation here. E bar is equal to rho s. In all charge densities, pico-coulomb per meter square is common. Means pico is 10 to the power of minus 12. Their magnitudes are different. 2 epsilon naught is 10 power minus 9 by 36 pi. Now I am writing direction. First one, dear students, ay cap. Anyway, I am just writing magnitude also here. Yeah, magnitude of charge density also we have to write. What is the first one charge? 20. Pico we have taken out, dear students. Again, don't write. Now tell me direction. Okay. Next, 20. What is this direction? It is at y equal to 7. So where is our field point? Where is your field point? Yeah, our field point is 2 comma 6 comma minus 4. Now I am just writing here the first bit. Field point 2 comma 6 comma minus 4. Where you have to concentrate, dear students, because the sheet is located in y equal to constant, your focus should be on y coordinate only. Look at FP is 6, source point y coordinate is 7, field point y coordinate is 6, source point y coordinate is 7. Now you tell me, dear students, FP and SP relationship. FP is 6, SP is 7. Who is greater? FP is less than SP. FP is less than SP. Then what is the sign here? Here minus. What is the sign? Yeah. Minus AY cap. Next one minus 8. Pico we have taken out already, dear students. Now you tell me for the second charge distribution. Field point y coordinate is 6. Source point is 3. Now you tell me here FP is FP and SP relationship. Tell me, dear students, FP is greater than SP because 6 is greater than 3. Very simple way you can decide. Now you tell me what is the sign here? Plus AY cap. Similarly, third one plus 6. You tell me 6 pico-coulomb per meter square is at y equal to minus 1 and here it is y equal to 6. FP is greater than minus 1, then plus. Last one, dear students, minus 18. Minus 18, multiply with unit vector. Tell me what is unit vector. For minus 18, y equal to minus 4, your field point is at 6. Then this is plus. Plus A by cap. Close the bracket, then you simplify. A by cap, you can bring it out. What is this? 10 power minus 12, 10 power minus 9. How much it is? 10 power minus 12. Because of pico we got this. 10 power minus 3. This will be 18 pi. Yes, students, it is 18 pi. What we have? 10 to the power of minus 3. And just I am writing here minus 20. And this is minus 8 plus 6 minus 18 multiplied with AY cap, dear students. Now you just have a simplification here. Minus 8 plus 6, it is minus 2. Minus 20, minus 2, it is minus 22. Minus 22, minus 18, minus 40, I think. 22 plus 8, it is 30, then 40. So it is around 40 into, you will be getting minus 40 multiplied with 18 pi 10 to the power of minus 3 AY cap. Dear students, use a calculator. It's maybe around 720 pi into 10 power minus 3. You'll be getting around minus 2.26. Minus 2.26 AY cap volt per meter. Dear students, check this. This you will get, you verify with your calculator. This is 720 pi into 10 to the power of minus 3. Just adjust the digits, you'll be getting around minus 2.26. This is for the first bit. Similarly, you can get it for second one. What is the second one? Field point. Minus 1, minus 2, 1.5. That also I am giving you, dear students. Yeah. B -1, -2, 1.5. Doesn't matter x and z coordinates, dear students. So what we have, -1, -2, 1.5. You should focus here only on y coordinates because the sheets are located in y equal to constant plane. That's all. Okay, yeah. Now, what is your electric field? Remaining same, 10 power -12 to 10 to the power of -9 by 36 pi epsilon naught, and this will be first one 20. Now tell me the sign, and we have -8, the second one, the third one I think 6, and fourth one is -20, -18. Yeah. Now let us decide the sign. So all these are having ay cap only. Now we can decide the sign by look at the source point and field point locations. Tell me, 20, -8, 6 and -18. Look at these magnitudes. Yeah, first one, y equal to 7, the field point is -2. So definitely field point is less than source point, then minus. Second one, look at the second one, we have y equal to 3, your field point is -2. Field point is less than source point, then minus sign. And the third one, where it is located, y equal to -1, your field point is at -2. Field point is less than source point, then minus sign. And the fourth one, y equal to -4, source is at -4, field is at -2. Field point is greater than source point, then it is less. Just simplify all these, we'll be having 18 pi again into 10 to the power of -3. I'm just writing -20, and this is minus of minus +8, -6, -18. Unit vector is ay cap. Look at the simplification, 8 minus 6, it is 2. And after simplifying this, -20, and this one is 2, -18 and -36. Then you are getting around -36 into 18 pi 10 to the power of -3 ay cap. Dear students, use a calculator. You check this calculation. Therefore, your answer will be, I think it is around -2.03 ay cap volt per meter. This is your answer, dear students. Check it once from your calculator. Okay? Yeah. This is about electric field due to sheet charge distribution, sheet charge density. This is on, after applying Gauss law, you will get this expression like we have seen for line charge distribution. Using that you can get. Okay? Yeah. We'll move to next one. This is another example application on Gauss law. This model I have told earlier when we discussed Gauss law, sin at equal to q enclosed is closed surface integral d bar dot ds bar equal to volume integral del dot d bar dv. Using that, they have given in this example d bar. One model is they'll give source configuration, they'll ask us to compute d bar or e bar. We have done it for the line charge distribution. Another model is giving d bar to you, they'll ask us to compute what is the net flux leaving or charge enclosed. In this, I have given 3 questions, dear students, one of the important model for your exam. In free space, means epsilon equal to epsilon naught, if d bar is r by 3 ar cap nanocoulomb per meter square, then calculate electric field intensity at r equal to 0.2 meters. The total charge enclosed within a sphere of radius r equal to 0.2 meters. The net electric flux leaving a sphere of radius r equal to 0.3 meters. For second and third, the mathematical approach is same, only they have changed the dimensions of the sphere, that's all. Anyway, I'll give you the solution for this. Yeah. So what is d bar given? R by 3 ar cap nanocoulomb per meter square. What is the medium? They have mentioned it is free space. Then what is E bar, dear students? Relation between E bar and D bar. E bar equal to D bar by epsilon naught. Why epsilon naught? Since medium is free space. For free space, dear students, epsilon r is 1 implies epsilon is epsilon naught. That's all. Relative permittivity of free space is 1. Now, what is this? R by 3 AR cap. Nano means 10 to the power of minus 9 divided by epsilon naught is 10 to the power of minus 9 by 36 pi. So 3 will come to the denominator, 3 by 36, it is 12 pi, you will be getting 10 power minus 9, 10 power minus 9 will be getting cancelled. Then E bar is equal to 12 pi R AR cap volt per meter. But they are asking us to find electric field at a given point specified, where it is at R equal to 0.2. Look at this, I am just substituting it. Therefore, E bar at R equal to 0.2 is 12 pi R is 0.2 AR cap. That's all. 12 into 3.14 into 2. 12 into 3 it is 36 into 2. Approximately I am writing. You will be getting your answer 7.53 AR cap volt per meter. This is your answer, dear students, for the first one. Now look at the second and third. I am just writing from Gauss Law. What is Gauss Law? We have Q enclosed equal to simplified equation dn multiplied with area. Without using integration, you can get it. Integration is not required because if you look at this d bar, which is along radial path in a spherical coordinate system, radial path is perpendicular to the sphere. No flux, we can find theta and phi direction. Okay, so what is this? D given dn normal component is how much? R by 3 10 to the power of minus 9, dear students. That's all. It is a normal component because for a sphere, radial component only normal component. Theta, d theta and d phi are tangential, no flux contribution. Even if you have taken it in surface integral, even if you use integration method, you will get the same answer. If you want, you can verify sin at equal to q enclosed is equal to closed surface integral d bar dot ds bar. We need to find flux leaving a sphere. Whenever you are taking sphere, that is defined from r equal to constant. We know d bar, dear students. We know d bar. I am just showing here. D bar is r by 3 AR cap nano. Anyway, we know that. And ds bar for r equal to constant sphere, it is r square sin theta d theta d phi AR cap. Look at this. Take AR dot AR, you will be getting the same. After simplifying this, this is nothing but area of the sphere. What is the area of sphere? 4 pi r square. Why should we take that complexity? Without taking that, we know the area of the sphere, which is 4 pi r square. I can write my answer. Then I can write from Gauss's law, sin net is equal to q enclosed is equal to dn is 10 to the power of minus 9. Dear students, I am writing nano r by 3 into area of the sphere where we are finding flux density or flux, net flux, 4 pi r square. So what is my equation now? Sin net equal to q enclosed is equal to r by 3. We can write 4 pi by 3 into 10 to the power of minus 9. How much? R cube. That's all, dear students. Whatever r is given, you can substitute, you will get answer within one line. This is our ready-made formula. So even if we use this integration method, look at this, dn is r by 3 AR cap and ds bar is r square sin theta d phi. Look at, we are integrating with respect to theta and phi. Integral of sin theta 0 to pi, you will be getting that 2. Integral of d phi from 0 to 2 pi in spherical coordinate system, you will get 2 pi. 2 pi into 2 is 4 pi. What is rest? R square into r. How much? 4 pi r cube. That you are getting. So 4 pi by 3 into r cube. That's all. We'll get the same without any doubt. If you want, you can check at your home, dear students. Yeah. Now once we know this, I can substitute radius value. In one example, they asked us to find what is the flux total charge enclosed within a sphere of radius r equal to 0.2. Another question, they're asking us to find what is the net flux leaving a sphere of radius r equal to 0.3. Okay, yeah, like I can substitute here, I can get my answer. The second one total charge enclosed within a sphere of radius r equal to 0.2 meters is equal to 10 to the power of minus 9 4 pi by 3 r cube. What is r? 0.2 whole cube. Radius is 0.2. Now you calculate using your calculator. You may be getting around 0.03351 nanocoulomb. Check your answer, dear students, using your calculator. You will be getting 0.0033510 nanocoulomb, or if you wanted to express in engineering units, 33.510 picocoulomb. Both are same, dear students. Just I have adjusted the digits. What is the third one? They are asking us to compute net electric flux leaving a sphere of radius r equal to 0.3, r equal to 0.3 meters. Radius is changed. Dimension of the sphere have been changed. Then what is that? 10 to the power of minus 9, 4 pi by 3, 0.3 whole cube. Then if you substitute after calculation, you may get around 0.113097 nanocoulomb. This is your answer, dear student. Check using your calculator, or else you can express in engineering units. I can write 113.097 picocoulomb. This is my answer. Both are same. One is expressed in nano, other one is expressed in pico. Okay? Dear students, I hope you understood this session. From this, you might have gained some knowledge how to solve, how to present your solution for various examples. Okay, students? Yeah. అయిపోయిందా?